Today we're going to look at solving simultaneous linear equations with algebra, the elimination method. The previous method of substitution was best when there was a variable by itself on one side of the equal sign. This method is best when that's not the case. The equations, though, need to be arranged so that the variable terms, equal sign and constant term, line up vertically. Usually when you start this work in Year 9, that's already done for you. In the more difficult problems, you would have to do that yourself. Now, the way we achieve this is we're going to add or subtract the two equations to eliminate one of the variables. And we add if the variable term is of the same size and opposite in sign. And we subtract if the variable term is of the same size and same sign. What happens if the variables are not the same size? Well, we target one of the variable terms in each equation and we choose the one that's easiest to change to the same size by choosing the smallest numbers to multiply by. We then multiply one or both of the equations by an integer to achieve the same size term. And then we add or subtract the adjusted equations. Let's have a look at some examples. In our first example, we see that the same size terms are the 4x and the 4x, but they're opposite in signs, so we should add these equations. The first thing we do is label them so that we can say our steps of working. So equation 1 and equation 2 I'm going to add. Now basically, we add each term separately. So 4x plus negative 4x, a plus and a minus is a minus. 4x minus 4x is 0, so that's gone. 3y plus minus 5y, a plus and a minus is a minus. So 3y minus 5y is minus 2y, is equal to 5 plus negative 3. A plus and a minus can be replaced with a negative 5 minus 3 is 2. To get y by itself, we divide by negative 2 and show our working. You can see the negative 2's cancel, leaving y equal to negative 1. Now we substitute that back into one of our equations. I'm going to choose equation 1. So where y is, we're going to replace it with a minus 1. So 4x plus 3 times y, here's where we're replacing our y, is equal to 5. Okay, so I've got to do this multiply, so 4x positive 3 times negative 1 is negative 3 equals 5. I'm going to change the side and change the sign, so this goes over here and becomes a positive 3. And so 4x equals 8, and divide by 4 to get the x by itself. 4's cancel, leaving x, and 4 goes into 8 twice. Now again, I can check my solution. In the equation I didn't use, I used equation 1 there, so I've got to use equation 2 to check. So equation 2 is negative 4 times x, I believe x is 2, minus 5 times y, I believe y is minus 1, and that should come out to negative 3. Do the multipliers first. That's negative 8. Negative 5 times negative 1 is positive 5. And negative 8 plus 5 is negative 3, which equals negative 3, so it checks. Therefore, x and y is equal to 2 and negative 1. That's where the graphs of these two straight lines intersect, and it's when x is 2 and when y is negative 1, it makes both these equations true. In our next example, we've got an equation, everything's lined up for us already, and the terms that are the same size are the two y terms, and they're also the same sign. So when they're the same size and the same sign, we subtract the equations. I'm just going to subtract in the order they're written. You can reverse that, but you have to be careful if you reverse it. So the first one we're doing is 9x minus 3x. I'll just put that there so you can see how it works. So those two minus signs become a plus, and 9x plus 3x is 12x. And the next one there is the subtraction. The reason we chose the subtraction is so they disappear, so they're gone. And that's equal to 3 minus 9. You don't have to put this extra step in if you're happy to do that in your head. Those two minus signs together become a plus, and so we end up with 12. So 12x equals 12. Now we divide both sides by 12 to get x by itself, and the 12's cancel out, leaving x, and 12 divided by 12 on the right is equal to 1. Now I'm going to substitute this value back into equation 1 so that I can figure out what y is. So replace x for 1 minus 2y equals 3. That gives us 9 minus 2y equals 3. Going to change the side of the 9, becomes a minus 9 over the other side. So we have minus 2y equals 3 minus 9, which is negative 6. Divide both sides by negative 2 to get y by itself. The minus 2's cancel, leaving y. A negative divided by a negative is a positive, and 2 goes into 6 3 times. Now, like all the equations we've done so far, we can check in the equation we didn't use. So I'm going to check in 2. So 2 says minus 3 times x, I believe x is 1, minus 2y, minus 2 times, I believe y is 3, and if we're correct, that should come out to minus 9. Now I'm doing the multipliers first. Negative 3 times 1 is negative 3, and negative 2 times 3 is negative 6, and negative 3 take 6 is negative 9. Whoops, I'll go up the top here. And that is correct. So, therefore, our x and our y is 1 and 3. So if we had the graphs of these two straight lines, they'd intersect at the coordinates 1, 3. And for our equations, when x equals 1 and y equals 3, it makes both of those equations true.